Welcome my lovely students to another video where we want to look at the science paper 1 for the 2024 for GCE. So this video will focus on section B. So we have the first question. Figure 1.1 shows an instrument used to measure a physical quantity, and this physical quantity measured by this instrument is called length. So this instrument is called the micrometer screw gauge. So there are parts that you need to know with their respective function. So this part is called the anvil, and remember the anvil is fixed, which simply means that it does not move. Then this one, part B, is called the spindle. The spindle can move back and forth, and in between the anvil and the spindle is where you place the object that you are trying to measure. Then this structure is called the frame. Then you will have the thimble. Then you will also have the nailing. So nailing can be used to rotate the spindle, the thimble, depending on the movement that you want. For example, one complete revolution of this makes the spindle to move a distance of 0.5 millimeters. Then we have structure E called the ratchet. So the ratchet is used to move the spindle back and forth, and also to prevent pressure from being applied on the object whose length is being measured. So now let's have a look at question A. So question A, we just want the reading. So we'll start with the main scale. Then the second one, we'll start with, second one is the vernier scale. So vernier scale tells you the scale that is moving. Right, so from the main scale, this is the main scale here. So from the main scale, we are just going to look at the numbers. So this number is 5. Then this is 6, 7. So the last line is 8. So you have 5, 6, 7, 8. So I'm going to write 8. Then you put a decimal. Then you go below here. As long as you have any line in between the 8 and this vertical line here, you need to add a 0.5 to the number that you have. So I'm just going to say 0.50 millimeters. So remember, we have readings in millimeters. But if this line down here was not there, we would have written as 8.0. Then from there, we go to vernier scale. So from the vernier scale, we are going to consider the line of reference. So the line of reference is this line here, the line that is moving from the main scale coincide with this line from the vernier scale. So we call it a reference line. So we have a 20, then 21. So the reference line is on point 22. So you say 22 multiplied by 0.01, which is giving us 0.22. So if we add these two numbers, we are going to get 8.5 plus 2 is 72 millimeters. So this is our final answer. We move on to B. So B is all about name part B. So we say D, that is the spindle. What over question E? So question C is what is the function of part labeled E? So E, we say it is ratchet. So the function of ratchet can be given in so different ways. So we can say to move the spindle back and forth, or to also prevent too much pressure applied on an object. For example, let's say you are measuring the length of a dust particle. So to prevent that from breaking, we can use the spindle, the ratchet to do that work. Then we move on to question D. So give one precaution you will take before using the instrument. So we can say clean the anvil and the spindle. So the reason why we are trying to clean it so that we remove any dust particles, because this instrument can measure anything, no matter how small that thing is. Or we can also say by zeroing. So if we say zeroing, it simply means that we need to make sure that the instrument reads a 0 before the measurement is done. Right, so we can now move on to question number 2. Right, so question number 2 is coming from the topic of simple machines. So we have figure 2.1 shows a wheel and axle. So we have a wheel and axle for a simple machine used to lift a load of 240 newtons when an effort of 60 newtons is applied. So we have been given a simple machine in a different way. I know that most of us were used to given maybe an inclined or a pulley system. So you need to know that there are so many ways in which these machines can be given. Even you can have a question where you are given a wheelbarrow seal. That's a simple machine. Right, so the first question is all about define a simple machine. So in simple way, a simple machine is any device that makes works to be easy. So anything that you use to make your work to be easy is considered to be a simple machine. Even a phone is a simple machine because in one or two ways it makes your work to be easy. Right, so we can now define a simple machine, but we need to remain with scientific terms. So we're going to say is a mechanical device. Which uses less effort to overcome a huge load. So it doesn't matter the explanation or definition that you are going to give, but as long as you need to make sure that you are within the principles of a simple machine. Now, if you look at question B is about mechanical advantage. Now, mechanical advantage is very simple. We know that mechanical advantage is equal to load divided by effort. So the load is the force that we are trying to overcome. Then the effort is the force that we are using to overcome the load. So we are given the load of 240 newtons divided by 60 newtons. So remember, this is a ratio, so we don't have to put units. So 240 divided by 60 will give us 240 divided by 60 will give us 4. So for this question, we are getting a value of 4. So that is our mechanical advantage. Then right, so that's our mechanical advantage. Now question C, if the radii, so we are given the radii of the wheel are an axle 80 centimeters and 16 centimeters respectively, determine the velocity ratio of the wheel. So for this one, you need to know that the bigger circle is considered to be the driven in terms of the axle or the wheel. So we'll call this one as the driven. Then the smaller one is the driver. So now you need to remember also that this question can be asked in so many different ways. at times you can be asked to find velocity ratio when you are given the speed of the driven and the speed of the driver. So in such a case, the formula for velocity ratio will be, so in such a case, you use n over small letter n. So this one is where you are given the speed of the driven and the speed of the driver. Now, sometimes you may be given in terms of number of teeth. So number of teeth, you need to say velocity ratio is equal to capital letter T over small letter t. So on top is the information is coming from the driven, then on the bottom is coming from the driver. But for the one that we are dealing with, we are dealing with the capital letter R and small letter r. So we'll say velocity ratio is equal to capital letter R, which is radius of the driven divided by radius of the driver. So make sure that the larger number is on top. So if we divide 80 by 16 will give us 5. So that's our velocity ratio. And also sometimes you may be given not radius but diameter. So you say d over small letter d. So that is what you need to know. Now for question D is all about the efficiency. So the efficiency is the ratio of mechanical advantage to velocity ratio, multiply the result by 100%. So mechanical advantage is 4, velocity ratio is 5 times 100. So if you divide these two numbers, you get 0.4 multiplied by 100. So the efficiency is 80%. So efficiency tells you how well a system is using the given energy with little waste in terms of energy. So we want at least out of 100%, 80% of energy is useful. Then 20% of energy is lost, can be in form of sound, friction, or heat. So it depends on how the system is operating. And remember, no machine is 100% efficiency. Question 3, a glass-sided box containing a mixture of smoke and air is illuminated and a microscope is used to view the motion of the smoke. Define diffusion. So this one is commonly known to say the movement of particles. From a region of higher concentration to a region of lower concentration. So to a region of lower concentration. So this simply means that the particles will move from the point where there is too much particles to a point where there is less, so that there is an evenly distribution. Then state two factors that increase the rate of diffusion. So number one, temperature. So whenever you increase the temperature of particles, then the diffusion will increase, because the particles will have enough energy to move from one position to another position. Then number two, size of particles. Size of particles, for example, smaller sizes are free to move. They are easy to move because they are light compared to larger particles. Even concentration is also another factor. Question B, state two differences between boiling and evaporation. So the first one is boiling is a fast process, while evaporation is a slower process. Number 2, we can say boiling produces bubbles. We are able to see bubbles when water is boiling. Wow, evaporation does not. Then in case you are asked maybe to give 4 or 5, the third one can be boiling has a fixed boiling point. For example, the boiling point of pure water is 100 degrees Celsius, while evaporation can occur at any point. It can be 30 degrees Celsius, 50, 70. So evaporation has no specific temperature. Then if we look at boiling, another difference, it can be that boiling occurs throughout the liquid while evaporation occurs on the surface of a liquid. Then we move on to question 4. So question 4, figure B4.1 shows the displacement distance graph for waves generated on a string. The first question, very simple. We want to define wavelength. So say is the distance covered by one complete wave. So one complete wave or cycle. So it depends with the definition that you know. If you know in a different way, your answer is still correct, so you can stick to that. So now let's move on to question number. So question number B, we just want the wavelength of the wave. So to answer this one, first we need to find how do we count a wave. So this part here, this is called the crest. Then this one here is a trough. So one crest and one trough makes a complete wave. So the wave is, let's say if this is point A, then this is point B. So from point A to point B makes one complete wave. So what number are we getting on point B is 10. So the wavelength is 10 centimeters. But remember, wavelength is given in meters. So say wavelength is equal to 10 centimeters, which is in meters will give us 0.1 meter. So now how do you change from centimeters to meters? You divide by 100. So 10 centimeters divided by 100 will give us 0.1, because 1 meter is equal to 100 centimeters. So from meters to centimeter, you multiply by 100. Centimeter to meters, you divide by 100. Then question C, what is the amplitude of the wave in figure B4.1? So the amplitude is the highest point reached by a wave from its rest position. So this is the rest position. This was the position of the string before it was disturbed. So from this point up to this point, this distance is our amplitude. So to find the answer, we need to go in the y-axis. As we can see, we are getting a 10. So the amplitude is equal to 10 centimeters. But the correct unit should be meter. So we say 0.1 meter. We can now move on to question number D. If the waves travel along the string at 0.5 meters per second, so this is the speed. Calculate a period D of the waves in figure B4.1. So period is equal to 1 over F. So period is the reciprocal of frequency. Remember, frequency is 1 over T. Therefore, period is 1 over f. So if we can find frequency, we can find the period. So let's find frequency. Remember this formula. Speed of velocity is equal to frequency times the lambda. So over lambda. Therefore, frequency excuse me, is equal to speed over lambda. So speed is given 0.5 meters over lambda. We found the lambda is 0.1. So if you divide, you are going to have 5 Hz. So 5 Hz is what I'm going to put here. So we're going to say 1 divided by 5. So 1 divided by 5 give us 0.2. So 0.2 seconds, which simply means that every after 0.2 seconds, a complete wave was produced, because period is the time taken for one complete wave to be made. And we can still also find the same period, but we can just reciprocate this. So the reciprocal of frequency is this lambda over speed. Lambda is 0.1 over 0.5. So if you divide these two numbers, you still get 0.2 seconds. So this will still work out. Question question 5. So question 5, what type of energy is in an infrared wave? So these waves have heat energy. In some books you may find it as radiation energy or radiant energy. Still the same. So give the range of frequency audible to the normal human ear. So we are looking at the range of sound that can be detected by a human being. So we need to first begin by infrasound. So the infrasound is any sound whose frequency is less than the range of human audible. So the range begins from 20 Hz up to 20,000 Hz. So sound with frequency greater than 20,000 is called ultrasound. Below 20 is called infrasound. So at times you may be given this question in section A, where I told you maybe from the given multiple choices, choose the multiple choice correlating with the human audible range. So if you haven't seen this one, so this answer can also be given as 20 Hz to 20,000 kilohertz. So remember, these two are still the same. So instead of writing 20,000 with zeros, you can just say 20k, because we know that k simply means a kilo. Kilo is equal to 1,000. Define an echo. So echo is defined as is the bouncing or the reflection. So the bouncing of sound. The bouncing of sound after striking a barrier. Barrier, we are looking at something in which sound cannot pass through. Then question D, a plane sends an ultrasonic sound down to the ground and receives the echo after 4.8 seconds. How high is the plane above the ground? Take velocity of sound in air is equal to 340. So let me give you a simple illustration. So we'll say this is a plane. Then this is our ground. So since there was an echo, sound traveled from the plane to the ground, then it bounced to the plane. So during the echo, we need to have two distances, the going and the coming. Now, for this one, we just need how high, so we just need one of these two distances. So now, how do you deal with this one? So you have to say speed is equal to, we know that the normal formula for speed is distance over time, but since there is the going and the coming back, you need to introduce 2. So our task is to solve for D. Speed is given 340 is equal to 2D over time is given 4.8. So over 1 we cross multiply, so 2D is equal to 340 times 4.8. So I'm getting 1632 over 2 over 2. Source distance is equal to 816 meters. Right, so move on to question E. Give one way in which sound pollution can be minimized. So we say by using soundproof. And there are some houses that are made in such a way that you can maybe listening to music with a full blast volume inside, but when you go outside, you feel as if the volume is too low. So such houses are made in such a way that they have the soundproof. Okay, we go to question number 6. Figure B6.1 shows a lens used to form an image drawn to scale. Identify the type of lens in figure B6.1. So to identify a type of lens, you need to look at what happens to light after passing through this. So if you look at this ray of light, it bends. Now the bending is that it bends here so that it can meet with this one. So as long as the bending, it's converging, it's bending and meet, then the type of lens is called the convex lens. So we have the convex lens, or sometimes you can call it converging lens. So to converge is to bend and meet at one point. Then he mentioned 2 characteristics of the image form. So you just have to look at the image, what you are seeing here. So if you look at the size of this image is greater than the size of the object. So that is our first characteristic. So the image size is greater than object size. Then the image is upside down. It's facing downward. Then you can also look at the distance of an image. This one, di, is greater than the distance of an object, which is do. This is also another point. Then the other thing is the image is formed beyond 2f, to the right side. So there are so many characteristics. So if you want this topic, you can just search for that. I have it as a topic. So, question C. What device uses this type of lens to produce a similar type of image? So cameras. So the cameras use this type of a lens. We move on to question number 7. So question 7 is figure B7.1 shows resistors connected to a 4 volts power supply. What is the effective resistance? So effective resistance same as total resistance. So what I'm going to do is first I'm going to find the total resistance of these two connected in parallel. So this is my resistor 1, my resistor 2. So to find total resistance, I'm going to use this formula. So you say resistor 1 times resistor 2 over the sum of these two resistors. Now to use this effectively, make sure you only have two. Resistor 1 is 6 times 12 over 6 plus 12. So 6 times 12, I'm getting 72 over 18. So if you divide by 18, you get 4 ohms. So if I were to redraw, this circuit becomes like this. So we've combined the two to form one. So here, this our 3 is here, 3 ohms. Then this is the 4 ohms. So we've combined the two. Now, how can we consider the other two? So these two now are connected in series. So to find the final answer, we'll say total resistance is equal to resistor 1, this one, plus the total resistance of the other two, which is the resistor 2. So resistor 1 is 3 plus 4, giving us 7 ohms. So now let me draw this simple diagram. So now this simply means that if you combine all these resistance, you're going to form one, and this is 7 ohms. So the total resistance of the whole circuit, if they are to be combined, is 7 ohms. Then B, calculate the potential difference across the 3 ohms resistor. So potential difference is voltage is equal to current times resistance. So to find the voltage at this point, we need current. Remember, resistance is given, is 3. So how can we find current? So current is equal to voltage over resistance. So we are going to find the total current. So to find the total current, we are going to use the total resistance. So voltage is 4 volts over resistance is 7, the total. 4 divided by 7 is giving me 0.57 amps. So we are going to say 0.57 times the resistance is 3. So 0.57 multiplied by 3, I'm getting 1.71 volts, which simply means that out of 4 volts supplied, 3 ohms is consuming 1.71 volts. Then the remaining will be consumed by the 6 ohms and 12 ohms resistors. Move on to question number 8. So question number 8, figure 8.1 shows a cathode ray oscilloscope. So we have the heater. Name the process by which the cathode rays are produced. So cathode rays, we are looking at a beam of electrons. So this is same as the process by which electrons are produced in a CRO. So this heater must be heated to a very high temperature. Then the electrons will gain kinetic energy, and because of that, they will be ejected. They will move away from the heater. Then they will move in this direction until they fall on the fluorescent screen. So the process is called thermionic emission. So thermionic, we have thermal, which is simply meaning the heat. Then state the function of the Y plates. So the Y plates will say to deflect the beam of electrons vertically. So you just have to look at y-axis vertical, x-axis horizontal. Then you move on to question C. Why is the potential difference between the cathode and the anode very high? So we are trying to ionize the gas pressure. Remember, the way the CRO was made, it was made to be evacuated or to be a vacuum. Why do we need it to be a vacuum? Because we know that if the dust particles were to be present in this CRO, the movement of the beam of electrons will be disturbed, because we know that the electrons are very small, so are particles. So the electrons can end up colliding with the particles that are in this CRO. So to prevent that, the CRO is evacuated. So this difference in terms of voltage helps to make sure that the pressure inside the CRO is very low. So remember, it is very low, about 0.01 Pascal compared to the normal pressure, which is the ATM. So now here, to simplify this answer, to make it simple, we can just say to accelerate the beam of electrons. Also to focus in one direction, and also we can say to ionize the gas pressure. Right, so we move on to the last question, question 9. So question 9, define nuclear fission. So don't confuse fission with fusion. So to fuse is to join. So fusion is where two smaller nuclides combine. Fission is to split. So say the splitting of unstable heavy nuclide to form lighter nuclide and energy. So remember, energy is also produced. Then B, what is background radiation? So remember, there are radiations that are man-made. There are also radiations that are present on Earth at all times. So the radiations that are present on Earth at all times is what we call background. So say this is a small amount of radiation. Present on Earth at all times. Then question C, state two uses of nuclear energy. So say in medical or in medicine, then also in agriculture. Then complete the following nuclear equation. So we have sodium as the mother atom producing magnesium daughter atom, beta and gamma. So as long as there is beta here, remember whenever it emits beta, the mass number should not change. So 24 will still be 24. Then what of atomic number increased by 1? So 11 plus 1 is 12. Then here we are going to put 0 minus 1. So this is our equation. So as you can see, it's very simple. So that's it for this video. Thanks for watching.